Yesterday we learned how to solve when you got an angle and you got a side. You can figure out another side. Okay, so on this one exactly, would you use opposite and hypotenuse for like sine? What you should do is label them, and you go hypotenuse, and from this guy's perspective, that's opposite and that's adjacent. So I have adjacent and opposite. Is there something like tau or so or ka or what am I looking for here? SOHCAHTOA. So which one works? TOA. Tangent, opposite over adjacent. So this one was tangent of 46. There's always a degree here. Even if there isn't, then there's a variable for a degree. And then is opposite over adjacent, which would be 15 over x, and you solved that yesterday. Well, what's different about today? Yes? You're finding angles. Notice I didn't give you an angle. I gave you a variable for the angle. So you need to figure out the angle. So on this one, what you do is the same kind of deal because we got the same situation. We don't have the hypotenuse. We have the opposite one and the adjacent one. So we use tangent again. Tangent of theta equals, what's the opposite one? 15 over what? 7. So then you could do 15 over 7 on a calculator and, move on from there. But how the heck are we going to get the theta alone? Yes, inverses. All right. On your calculator here, right above sine, cosine, and tangent, you'll see sine with a -1, cosine with a -1, and tangent with a -1. And what are they called? They're called inverse functions. The inverse sine, the inverse cosine, inverse tangent. All right. So those are going to help us, and I'll show you how. Remember how I had this set up? Tangent of theta is opposite over adjacent. Tangent of theta equals 2 point, somebody tell me what is that? 15 divided by 7. 2.14-ish? Okay. So now, here's the way I'd like you to think of this. We can't just type in tangent theta. There's no way to do that. So we want to get the theta alone. It's a lot like solving an equation. If I was solving an equation that had an x in it, you know how I always try to get rid of everything until I just have the x left? What am I solving for here? Theta. I have to get rid of the tangent. How do you get rid of a tangent? With an inverse tangent. And if I do it to this side, I have to do it to the other side. I have to do an inverse tangent here. And then this and this get rid of each other, and I've got theta equals inverse tangent of 2.14. So now take your calculator, do inverse tan, 2.14, enter. Theta equals 64 point something? 5 or 9? 9.5. Well, that's why I heard 9 and a 5. All right. So moral of the story. I'm going to go back in time here. So you get this normal looking, this is the way you normally set them up. And when you're trying to solve for theta, you get rid of tangent with inverse tangent. Like that. And inverse tangent on both sides makes it cancel, and you'll just have theta left. All right. See if you understood that well enough to find theta for yourself. I think this is a review from last year, but I don't know. I think for some of you it is, some of you it might not be. Yes, we start with that one. Tangent of theta is opposite over adjacent, 5 over 2. That's tangent theta is 2.5. How do I get rid of the tangent so that the theta will be all alone? Inverse tangent, these are gone. Theta is tangent to the -1 or inverse tangent to 2.5. What did you get? Raise your hand if you had the same thing. Good. When I get the feeling like everybody's getting it, I don't want to waste your time on these. I had several examples planned. I don't think we need to do all of them. So I'm going to move on to the next topic, which is Dr. Jekyll goes with what? Mr. Hyde. They like, you know, like kind of like yin and yang. How about Minnesota Vikings? Green Bay Packers. No, that's like kind of the opposites, sort of. Okay. Well, sine, cosecant. They're kind of like that. Cosine, secant, and tangent, cotangent. They're kind of like the crazy sister that's like completely opposite. All right, so sine, let's go through SOHCAHTOA quick and just remember the sine, cosine, and tangent. What's so, tell me? And ka and toa. Take a wild guess what this one is. Hypotenuse over opposite. And this one? Hypotenuse over adjacent. And this one? Adjacent over opposite. All they are is they're flipped. What did we call the title of this today? It was inverses and what? Which one is this? Reciprocals. And don't call them inverses, because it's really easy to do that, but your pre-calc teachers will go nuts on you next year, because it's not the same thing. I know you think inverse and you think reciprocal and you think that maybe they're like the same thing, but they're not. So anytime I want to figure out a secant, what I'm really going to do is figure out the thing that's more familiar to me, which is what? Cosine. And then all I have to do is figure out the cosine and do what to it? Or flip it. So if my answer here was 3/4, cosine of 3/4 would be the same as secant of 4/3. All right. Now if you have a hard time remembering which one goes with which, and you will, maybe you will remember this perfectly if you just keep this in mind. These make total sense. Tangent, cotangent, sort of like pilot and copilot. Doesn't that make sense? Those kind of go together. But sine and cosecant, I mean, those don't just like ring. They don't make sense just by themselves. So I'm going to try to underline the part that's important here. Every S goes with C and every C goes with S. So if I start with a C, you know that the inverse to that starts with an S. If I start with something that starts with S, then you know the inverse to that has to start with a C. All right? So if I get rid of these for just a second, and don't look at your notes, if I start with secant, from what I just told you, what does the other one have to start with? A C, right? And so which one is it? Cosine. And I know the most common mistake here is secant and cosecant go together, but they don't. If you look back here, secant and cosecant, it's so frustrating that they use those names for them, because it just doesn't make sense. It doesn't ring. You know, it should be like, you know, sine should be with cosine, and secant should be with cosecant, and tangent should be with cotangent, but it doesn't work that way. And if you go through the you know, deriving them, you'd understand more about why, but that'd take us a long time. So let's just kind of get these through your head. If I did sine, starting with an S, what's the inverse to that one? Starts with a what? C, and so what must it be? Cosecant. And if I have tangent, how about that's the logical one? What does that go with? Cotangent. And if I started with secant, I'd have to start with what letter here? So which one is it? You getting which ones go together? Because once you get that, all you have to know is that this flips over. That's all there is to it. All right. So if I was doing cosine of theta and it equaled 4/5. Okay, we'll do that on the next table.